So we're going to be asked to find the slope of the line. We're going to show that it's constant with those similar triangles. We're going to show unit rate and slope can be interpreted as the same thing. Again, we'll look at our graphs, tables, and equations. So as we are working on this, you please set that aside. We are going to write down our definition. So our definition of slope. The definition of slope. When we think about that definition, the definition of slope is, someone have a definition if you wanted to look back. What is something that it looks like? Definition of the slope of a line. That definition of slope, it is the measure of the steepness of something. For us, most of the time that something is going to be our line. The other thing that we know with our definition of slope is that when we look at that slope, that is our unit rate. So it's going to be our unit rate only in proportional relationships. Some of you did an awesome job telling me what that proportional relationship was on the quiz. You said it's a straight line, has a constant rate of change, and it went through the point 0, 0. So that is what I was looking for on the test. I needed to see the 0, 0, and that it was a nice straight line. So next thing we want to put down is we want to write our formula. So if we are writing our formula from today when we were looking at formula, Matt, what do we have for our formula? The M, the movement, was what? Y sub 1. How about y sub 2? Yeah. And what you're going to sometimes see with this formula is that they will say, and x2 minus x1 cannot equal 0. What happens when we divide by 0? Dan, what happens when we divide by 0? It's undefined. Undefined. No, not right now. I need you here. So next thing we are taking a look at is our description. Okay? When we look at the description, words we might be using might be our steepness. We might be looking at change in y divided by change in x. We might be looking at writing down that this is our rise going up, positive, down, negative, over the run. Make sure you're writing this down, please. Here, when we talk about our rise and run, to the right is positive and to the left is negative. So that was on that worksheet that you were doing as we were looking at those. Okay? Doesn't your pencil work? Write that, please. That last part that I had. So now as we are taking a look, we want to take a look at that next problem comparing two lines. Okay? So as you are looking down at problem 1, comparing the two lines, it says, how can you tell if line A and line B are the same line? They go through the point 0, 2, 610 for line A. Line B goes through 610. Now look, when they get to that 610, that meant they went over 6 and up 10. This is not going left or right and going up 2. This one is saying to go over 10 and up 16. It says if we plot 2 points and they look like they might be on a straight line, we can't use that for our judgment because sometimes rulers are bent, like some of you bent my rulers, but we need to make sure we are making sure that these work. So what we need to do is we need to find the slope. So our definition of slope, that's our M, our movement. We are going to, in this case, subtract. Now, since it's a graph, we're going to count the rise instead of subtracting. We're going to count rise over run. How far from, and you always want to start from the point furthest on the left, and you want to go from left to right. So from 2 to 10, how far are we going up? 2 to 10. 10 minus 2 gives us how much? 8. Then we want to look how far are we going across. And this is when we take our x-coordinate. So our run is going from 0 over to 6. So we're really taking 6 minus 0, which gives us 6. We move 6 units to the right. Does that make sense to everyone? Okay. So I want to simplify my slope, just like on your worksheet today. I'm going to ask you to simplify. This becomes 4/3. That's for line, I'm going to call this my line A, and this is going to be line B. So this was the slope of A, and now we want to look at the slope of B. If we are taking a look at the slope of B, again, we want to think about that rise over our run. So if I'm going from this point, which is located at 610, and I'm going changing my y coordinates, right? So from 10 to 16, how far am I going up? 16 minus this 10, the y's, right? This is like my y2, this is my y1. How far am I going up? What is my rise? Should be 6. 16 minus 10 gives us 6. Okay. How far is my run going from 6, this x1, to my 10, x2? 10 minus 6 gives us a change of 4. Simplifying that gives us 3 over 2. And the question was, is this the same line? And our answer is going to be no. And the reason it is not the same line is because the slopes are not the same. So these 3 points are not on the same line. So it says, if we plot the points, does it look like they will be on the same straight line? The slopes are not the same, so the 3 points are not on one line. Please make sure you can at the right. The other one has a slope of 2, and it goes through the point 10, 23. Are they the same line? So this is what we want to do first. We're going to call this our line A. We're going to think of this one with this other point that they're giving us as this is going to be line B that goes through here and has a slope of 2. So if I am looking at the slope of A, to find the slope of A, rise over run. Caitlin, if we're subtracting our y points, y2 minus y1, can you tell me what numbers I'm going to put to subtract?
9 minus 3.
9 minus 3. If I take 9 minus 3, Riley, what am I going to subtract for my x points? x2 minus x1.
3 minus 0.
3 minus 0. So noticing this is x, y, x, y. So 9 minus 3, 3 minus 0. This leaves us with 6 over 3, which is 2. So the question is, are these two going to have the same, are these two going to have the same, they're going to be the same line? They both have a slope of 2. And it tells us that it already goes through way up here. It goes through, if I was going to plot this, it would go through the point 10, going way over to 10 and up 23. So because they have the same slope, what we are going to write down is that they are going to be on the same line as we look at that. So when you are filling this part out after putting that slope, we are going to put, yes, they are both the same line as we look at that. Why are they the same line? They have the same slope is what we are looking at, okay? Our line is located at 0, 3, 4, 7. There is another point on the same line with the location 36y. What number does y have to be? You're going to see at least 3 or 4 of these in your homework like this. I will recommend that you go back and look at this problem again and maybe listen to the video or look in your notes carefully. The first thing we need to do, we're going to call this our points A, right? And this is going to be kind of our B, and we are going to use that. So if I find the slope of line A, I might write above that as I'm looking at this, what would you say, Ashley, is my X points? Can you tell me how to name these up here?
0 would be x1.
Yep.
And then y1.
Yep.
And then x2 and y2.
Thank you. All right, so Kendall, we want to find our slope. We're going to use that formula, y2 minus y1 over x2 minus x1. Tell me what I should write. 7 minus 3. Rowan, what am I putting in my denominator then if I put 7 minus 3 in my numerator? The x2.
You put 4 minus 3.
4 minus is 0. Yep. So 7 minus 3 gives us 4. 4 minus 4 gives us 4. That means I leave it as a slope of 1 over 1. Please write that down. Slope of 1 over 1. Someone said, isn't that just 1? Yes, but here's what's really important when we are now trying to find the location of y. So if you're going to find, and this will be the same in your homework if you're trying to find the y or the x. The key thing, I would always go with the smaller point. So we're going to, when you find y, we are going to use the smaller of our 2 points, which is 0, 3. We would want to think of this as my x2 and my y2, okay? Up here, 36 comma y, this is going to be my x1. Please write that, some of you aren't writing anything. This is going to be my y1. So Joe, we're using that same formula. And this time my slope of b, if I'm going to look at that. But this time I know what m is, and our formula, y2 minus y1 over x2 minus x1. So Joe, help me out. What am I going to put for my y2? You know what? Let's switch, Let's switch this around, my fault. You're just going to change the little numbers down below here. We're going to call this our x1, this is y1, we're going to call this x2 and y2, okay? So the unknown is always going to be your second, if it's the second y or second x when we look at it. Okay, so now, Joe, tell me what I should write.
4 minus 3.
So I'm going to have, oh wait, this is y. So we're going to have y minus 3 over, in the denominator, what should I write? 36 minus 0. So we're going to leave this as y minus 3 over 36. Here's the deal. The slope was supposed to be 1, right? This slope has to be equal to 1. What number how can I write 1 with a denominator of 36? How would I write that? As a denominator of 36, John, what can I write 1 with a denominator of 36? What does it look like? 36, not divided by 1, but 36 over, not over 1, it has to equal 1. What am I going to make it so that it, 36 over 36. So what you have to do for this part, and this is probably the trickiest part, this slope has to be 1. But we don't want to write 1 here. We want to put 36 over 36. These two are already the same. Do we have to do anything to find that number? No. What you need to do is you've got to find what y is. So if I'm trying to find y, I know this equation on the top. So please write down y minus 3 equals 36. What does y have to be? I'm going to add 3 to both sides and get? I'm going to add 3 and get 39. If I would put in 30, if I go back here and plug in 39 minus 3, I get 36 over 36. So this is what you're going to be asked to do on your homework. And I know, looking at this problem, it gets a little hard. We haven't had students do this in the past, but this is pretty important for you to understand and going forward as we are doing the lesson. So, as you would turn right now to your homework, it is back on page And then you're going to look at that worksheet. We are going to take a small homework quiz today. So this is on page 61. 60. And 60, 61, so the assignment that you're doing is page 60, 61, and 62. Okay? 3 pages. Takes a lot of pages for these big graphs. So this first one, they say, look at line PQ. They tell us it's a straight line. It says we have 3 similar right-angled triangles that have been drawn beneath. They are not drawn to scale. Calculate the length of A and B. So, key thing, when we do our slope, we might find the slope, this might be our A, this might be B, this might be C. Although maybe we should use other letters than A, B, and C, because they use A here and B here. So maybe we use J, K, and L, right? So this part going from here to here is going to be the slope of J. Can you count it? Rise over run? What would I be putting down as I am looking at rise over run, Nolan? No. We don't have any of those points. What do you have here? The rise is how much? 6 over 8. Simplify it to what? What are we simplifying that to be equal to as we look at it? 3/4. I am now going to put K. I am going to keep using this one, right? So now I'm going to put the slope of K. Keep in mind, it has to be the same slope as this one, right? So I'm going to put the slope of J, which is 3/4, has to be equal to 9 is the rise, A is the run. Do you know how to solve that problem? You could say, oh, what do I take times 3 to get 9? I take times 4. Or if you remember from last year where you did the cross multiplying and you were solving this as an equation, you could say, oh, 3 times A equals 4 times 9. 3A equals 36, and you could solve it that way. I don't care which way you solve it. You have to tell me what A is equal to, right? When you go to this one, you got to find B. B is the rise, right? So when we look at the slope of L, I am looking at 3 to 4 equals, you need to figure out where you put your B in 10. This question here is almost exactly the same as what we just did in our notes where you were checking. You need to find the slope of this region A and the slope of B in order to tell me. Down here, this is the tricky part. This is like that last problem we did. It's like this, problem 3. So this problem 3 here is a lot like our problem 3 of looking if it passes through those points. You need help with that, please come in. And then this last part, they're going to ask you which line is the steepest. Can you calculate each of these slopes? Line A. So which one is the steepest? I would find the slope of A. I would find the slope of B. I would find the slope of C. And the slope of D. You want to find all those. What's the easiest way? Well, you might want to do the y2 minus y1 over x2 minus x1. Someone else said, well, can I count? Just make sure when you count going up, you're looking at the y's, right? When you count going across, you are always looking at your x's, okay? So you just got to make sure, or use the formula, right? That formula always works if you're not sure. You don't want to get them mixed up. It's never run over rise. It's always rise over run, okay? So